46,
Present, sir.
47, 48, 49, 50, 51, 52, 53,
Present, sir.
54, 55, 56, 57,
Present, sir.
60,
Sir, 59.
59,
Present, sir.
60, 61, 62,
Present, sir.
63, আচ্ছা আর নেই।
স্যার 148 শান্তনু বর্মন বলছে স্যার। স্যার লেট জয়েন করেছে একটু। 148।
হুম ঠিক আছে, আর কে আছে বলো?
Sir, 149.
149 দেন। কেউ ল্যাটারাল আছো?
Yes, sir.
হ্যাঁ স্যার।
বলো
Common
বলো।
Burai 1013.
আচ্ছা তোমাদের এটা আমি জানি না, আমাকে পাঠিয়েছে, আমার তোলা হয়নি এখানে। আরেকজন কত? 10?
1013 Common Burai.
আচ্ছা ঠিক আছে, আমি পরে তুলে নেবো ওখান দিয়ে। তোমার নাম যেটা দেখাচ্ছে স্ক্রিনে আমি সেটাই লিখে রাখলাম, ঠিক আছে?
Yes, sir.
1013। আর আর কে আছো?
Sir, 1011.
1011 তো অর্ডারে বলো। হ্যাঁ,
Okay.
1011 তাই তো?
হ্যাঁ স্যার।
ঠিক আছে। কি নাম?
স্যার সুমিত সাহা।
তারপরে?
স্যার 1009।
1009। কি নাম? হ্যালো হ্যালো।
হ্যাঁ স্যার।
হ্যাঁ নাম বলো। হ্যালো।
হ্যাঁ স্যার শুনতে পাচ্ছেন?
না শুনতো, হ্যাঁ নামটা বলো একটু।
মুভি।
আচ্ছা তোমার স্ক্রিনে যেটা দেখাচ্ছে সেটা আমি লিখছি, হ্যাঁ দেখে নাও স্পেলিংটা।
ওকে।
হুম ঠিক আছে।
হ্যাঁ স্যার।
হ্যালো। হ্যাঁ আর কে আছো?
স্যার একজন জয়েন করতে চাচ্ছে।
এখানে আর কেউ নেই তাই তো? আচ্ছা ল্যাটারাল আরো আছে। ঠিক আছে, তো ওরা জয়েন করুক। এখনো জয়েন করেনি তাই তো? ঠিক আছে, আর কে আছো? আর কেউ আছো লেট জয়েন করেছো বা কিছু? হ্যালো। ঠিক আছে, আমি বলে দিচ্ছি 139 প্রেজেন্ট, 140 প্রেজেন্ট, 141, 142 প্রেজেন্ট। তারপরে হচ্ছে 145, 46 প্রেজেন্ট, then is 48, 49 present, then is 153 present, then is 157.
Sir,
বলো
150. 150.
হ্যাঁ আচ্ছা তারপরে 150, then 153 present, then is 157, 59 present, then is 161 present, 162 present, 1009 present, 1011, 1013 present. ঠিক আছে? So today we'll be starting the তাড়াতাড়ি বলো কে কে জয়েন করলো। So today we'll be starting the fifth experiment. So today we'll be starting the fifth experiment, which is torsion testing machine. ঠিক আছে? So you have studied about torsion. Attendance কার বাকি আছে আর লাস্টে জয়েন করলে?
154 রণজিৎ দাস।
আর anyone else? So have you studied about torsion? Torsionটা কি পড়েছো? So you have studied about torsion. So the So this is the experiment sheet for torsion testing experiment. So we'll be looking at the presentation also. So I don't have the slide for this one. So I'll be explaining it directly from the lab manual, and then we'll be having a look at how the experiment is getting conducted in the laboratory. So this is the torsion testing of mild steel. So generally we do the torsion testing and tensile. So these two sort of experiments are mostly done for the ductile material. So mild steel is a ductile material, widely used the sort of ductile material. So on mild steel, so what will be happening is we will be applying a torque on the specimen and we will be measuring the angle theta. So as we know that the shear stress, so you are applying a torque, so you are actually applying a shear stress on the material. So along with that, along with the shear stress, a shear strain will be put on the material. So we know that within the elastic limit, as we have with the tensile testing, within the elastic limit, you will be having the shear stress will be proportional to the shear strain. So as in the case of tensile test, we had tensile stress is proportional to tensile strain. So we got sigma is equal to E epsilon. And in case of torsion testing, you will be having the shear stress is proportional to the strain. So you will be having tau is equal to, or tau is proportional to gamma. So you will be writing it as tau is equal to G gamma. So the constant of proportionality is known as the shear modulus. So as in tensile test, we call it the Young's modulus. So in case of torsion testing, the same constant of proportionality, we will be calling it as the shear modulus. So shear modulus is given by shear stress divided by shear strain. And Young's modulus is given by tensile stress divided by tensile strain. So in this experiment, we need to determine the modulus of rigidity or the shear modulus of the material and the breaking torque. So how much of the torque is needed to break the material in torsion. So the apparatus that we are using is a torsion testing machine. The maximum capacity of the machine is 60,000 pound-inches and the maker of the machine is Avery & Co. So in this experiment, you know this within the elastic range, as you told that you know this or you have rather studied about torsion. So in torsion, we know that T by, you know it actually, T by J is equal to G theta by L. So this comes directly from that relation itself. Okay, so we can derive these things. So I am not going in the derivation. So this G is known as the shear modulus of the material or the modulus of rigidity of the material. Capital T is the applied torque. Capital L is the length of specimen. Theta is the your angle of twist corresponding to the torque theta. So theta in this case is the angle of twist. And sometimes we also call phi. So phi is theta by, so theta by L, the torque, the angle of twist per unit length, that we call it as phi. So theta is the total twist that is occurring due to the torque capital T. Okay, sir? So this is it, and J is known as the polar moment of inertia of the cross-sectional area. So polar moment you have studied that normally you have Ix, Iy, and since in case of torsion the material is being rotated about the Z axis. So you have to consider the polar moment of inertia, Iz or Ip, whatever you call it. So in case of torsion, we have to consider the polar moment of inertia of the cross section. So generally, the mild steel specimen that we will be testing in torsion, that is a circular cross section. So that is why the polar moment of inertia that will be given by Ip or Iz, that will be given by your pi by 32 d cube. So same thing, the effective lengths are measured and all. So Igla will be going to the experimental sheet, and then we'll be looking in this one. So here initially we'll be measuring the angle of twist theta. So we'll be giving an angle of twist. So there will be a lever sort of arrangement, and with that actually we will be rotating that one, and then we will be applying a twist on the specimen. So that twist initially we'll be measuring in degree, and then we have to convert it in radians, and then the torque in Newton meter we have to measure. So this is the machine that is a make of it's a very old machine actually. So generally the values will be coming in pound inches. So those values in pound inches you have to convert it into Newton meters. So once you get those things actually, so from there you have to plot the values of T and theta. So as in tensile test you have plotted Fx, I mean force versus deflection curve we plotted. F delta curve we plotted. Okay, and similarly we plotted the stress versus strain curve. So similarly in this case also we have to plot the shear stress and the shear strain curve. So initially you have to calculate the shear stress. So the shear stress tau, as you know, like that will be given by, for a circular cross section it will come out to be something like 16T divided by pi d cube. Okay, so from there you have to calculate the value of tau, the shear stress, and then you have to calculate the shear strains. Shear stress you calculate it, and the shear strain will be given by something like r theta by L or r theta rather. Okay, theta by L. From there you have to calculate the shear strain. So once you get those things, you can calculate this one. So for everything, so for all the data actually, so you have to calculate for all the values of torque that you are getting. So you are getting T and you are getting theta. So from T, আমি complete করে নি একটু. So theta j পেয়ে গেলে, so once you get the value of T, so since tau is given by 16T divided by pi d cube, I think you know. Or if you don't know, I have to derive. Just if you know, I will not derive. So tau is given by 16T divided by pi d cube. So once you get this value of T, so for the experiment number 1, so for the reading number 1, you got a value of capital T, you got a value of theta. So from the value of T actually, so you put it as 16T divided by pi d cube. So you get a value of tau 1. And similarly from the value of theta, once you put r theta by L, you will be getting the value of gamma 1. So once you get tau and theta, and then you divide the two. So modulus of rigidity is the ratio of shear stress divided by shear strain. So you get the modulus of rigidity by calculation. And then you have to calculate a mean value. So you are having 10 or 20 readings, say suppose. So you have to take the mean of all those readings, and you will be getting a value of mean modulus of rigidity of the material. And then you have to plot a graph. So once you plot the graph, so same sort of graph that you got in the case of tensile testing. So initially you will be having a like linear region, and then after that it will be switching on to the plastic zone, and then the thing that you have to plot, and then this value you have to match actually.
সুমন বলেও একজনের আসার কথা।
হ্যাঁ, সে তো ঘুরতে ঘুরতে আসবে এখানে, আসার কথা আছে, মানে তার তো হ্যাঁ কখন ট্রাই করবে? 2:30 তো 2:30 থেকে ক্লাস তো। So at least 230, 235, 240 is allowed. 250 এসে যদি জয়েন করে তো মুশকিল না, আমাকেও তো ক্লাসটা করতে করতে আমাকে মানে ওইটা অফ করে আমাকে ওয়েট করতে হচ্ছে না। অ্যাটলিস্ট 5 মিনিটস 10 মিনিটস সেটা অ্যালাউড আছে। এতজন দেখো এত পর জয়েন করছে।
Sir, have you done the attendance?
ঠিক আছে, সবাই জয়েন করে গেছে নাকি আর একটু ওয়েট করে নেবো? আর কার অ্যাটেন্ডেন্স একটু তাড়াতাড়ি বলে দাও।
স্যার 155 কৃষ্ণগড়।
আর আর কে আছে?
Sir, 160 Shuman Acharya.
আর নেক্সট 1 আর এনিওয়ান এলস? আর কেউ আছো? হ্যালো, ওকে। So I think we were discussing about this. So initially, so you have to calculate shear stress, then you have to calculate the shear strain. So this shear stress divided by shear strain for all the readings you have getting the value of the shear modulus. So by calculation, you will be getting one value of the shear modulus, and again you will be getting one value of the shear modulus from the graph. So you have to plot the graph, and then within the linear region, you have to take the ratio between the shear stress and the shear strain. So from there, you will be getting the modulus of rigidity. So just remember that when you are calculating the modulus of rigidity, the slope you have to take within the linear region. So as like Hooke's law, it was defined as within the elastic limit, the stress is proportional to the strain. So this Young's modulus or the shear modulus, they are only defined within the elastic zone actually. So in all those readings, how do you understand that the reading has switched to the plastic zone? So once you go on increase the stress, a point will come that you are going on increasing the, but that you don't increase the stress too much, but still the shear strain goes on increasing. So the material has actually yielded, or it has moved to the plastic zone, so that without applying too much of a shear stress, actually the material starts yielding or deforming by itself. So whenever you see that the stress is not increasing too much, but strain is increasing at a higher rate actually, so in those cases you can understand that the material has switched to the plastic zone, or the elastic zone has ended. So within the elastic limit, so wherever the elastic limit ends, actually within that at any point, you have to take one point, and then you have to take the slope of the curve of the shear stress and the shear strain curve, and the slope that will be giving you the modulus of rigidity value. So let us now have a look at the experiment actually that has been conducted. So I think the sound is visible from your end, or is audible from your end, I don't know. So let me start from the beginning. So this one is the torsion testing machine as we had discussed. So initially you can see that there is a dial, and this is the specimen. So the specimen is similar to the specimen that we had been using in the tensile testing. You can see that there are two ends actually. So the ends are actually just for gripping, and there is a effective length, or the gauge length portion actually. So you can see that the two ends, they are actually made for gripping inside the jaws of the torsion testing machine. So the jaws, one of the jaw that will be moved to the right, and the specimen will be fitted in that position. So in between actually whatever is the length, that is known as the gauge length of the specimen, and then that gauge length will be used in calculating the calculating all the things, like whenever you are calculating shear strain using r theta by L and all those things. So that gauge length you have to take into account, not the entire length of the specimen. The end lengths are actually for the holding of the specimen or securing the specimen into the jaws. So here you can see that there is a hand wheel actually that is used for actually applying the torque or twisting on the specimen. So once you rotate this hand wheel, actually you can apply the twisting on the specimen. So this is regarding the jaws and all. So there is a lever sort of thing actually. So in this is as I told you that it's an older machine actually. So there are actually two scales actually. So two scales means one scale is for there are two limits actually. I don't remember the limits actually. So one is, I think, like there is a limit like whether 1000 of the, if you want to test up to 1000 or 1500 something pound each, you can use the you can use one scale, and there is and if you want to measure more than that, actually you can use the other scale. So in order to switch between the scales, actually there is a lever sort of arrangement that has been given. So as now you can see that the specimen is getting fitted on the machine actually. So these are the scales actually. So you can see actually there are two scales actually. So just I couldn't see actually. So you can see that there are two concentric scales actually. So the inner scale actually that is used for measuring lower amount of the torque, and the outer scale that can be used for measuring if the torque is higher than that range actually. So based on the range of the torques that you are applying on the specimen, or rather you are measuring, so that you can measure on the user that for that you can select the scale on the machine actually. So here now just a marking is being done on that one actually. So since you are twisting the specimen actually, so you are making a straight line on the specimen, so that once the specimen gets twisted, actually the straight line you have drawn on the specimen, you can understand that the specimen is getting twisted. So this is how the specimen is being secured in the jaws actually. And this is the thing actually, the main thing. So here you can see that the torque on the specimen can be measured actually, and there is a circular scale rather, and along with it a vernier scale has been placed actually. So if there is a very small theta actually which you are unable to measure, so that you can measure from the vernier also. Okay, so you have studied about Vernier scales, I think. So what is a Vernier scale? A Vernier scale, you can actually measure two or three things at a time actually. So you can measure more finer things you can measure using the Vernier scale actually. In between divisions, you can measure. So you can see that there is a main scale, and along with that, a Vernier scale has been placed. So wherever there is a measurement, so once you measure, take a reading from the main scale, and then you take a reading from the Vernier scale, and then you apply the Vernier, multiply it by the count and all, and then you will be getting the actual rotation of the occurring inside the specimen. So I think you can see it clearly now. I think so now there is a forward and reverse, so you can rotate it in both the directions actually. So this is about, I think, the zero. Okay, its place in the zero setting is done, I think. Okay, so initially if it's not set to zero actually, so you have to do some zero setting on the machine actually. So just some zero settings had to be done on the machine. So this is this. So the experiment has been started, I think. Yeah, the experiment has been started. So now you can see that the torque is being applied on the machine, and that is being recorded on the bigger scale, the vertical scale, and this one. And on the below scale, you can measure the torque actually, the theta value actually. So now you can see that the line has been tilted, I think. Here at least, hello? Hello? So here I think you can see actually that initially the line was straight. So they drew a line which was like totally horizontal. So since you are twisting actually, so you can see that the straight line has been twisted actually. So this is the twist on the specimen actually. So see that line has been twisted. So now you can see that the right jaw that is actually rotating and the left jaw is fixed actually. So when the right jaw is rotating, it's putting the torque on the specimen. The torque is being recorded as well as the theta is being recorded. So you can do it on the reverse side also. So I think it's being done on the reverse side. No, so you can see that the specimen has been twisted. Okay, so whatever is the twist that has been the torque that has been applied on the specimen, so it's a very large value because it's in pound inches actually. That has to be converted into like Newton meter. So now you can see that the specimen has been twisted too much actually, resulting in a plastic zone actually. Here you can see that the straight line, you can see that initially it was straight line. Now it has become a totally like kibolbo. Totally it has become a like twisted line. So in this way, you go on applying the torque on the specimen and you measure the value of theta and you note down whatever are the values. So here you can see that it has the line is totally twisted and the twist lines are appearing on the specimen. You can see clearly that there are certain like twist lines that are actually occurring on the specimen. So here you can see the straight line that's actually it's totally rotated. So here you can see just the fracture part. Let us see. So this is occurring. So now the specimen will at some point fracture. Because the fracture didn't occur actually. It occurred at the jaw. I think it just at the last day I discussed actually. I just had a discussion with you on the last day that since the specimens are not made up to the finest standards, unless that is the specimen should have fractured somewhere in the middle actually, but it fractures just at the end actually. Okay, so that's somehow because the loading has to be very much uniform, very uniformly the load has to be applied and all those things. Many precautions has to be followed. But you can see that it has the specimen has broken near the fixed jaw actually. Okay. So now we are just taking the dimensions of the specimen, the reading. So here you can see that the angles has been measured and on this side the torques have been measured. So once you get the readings actually, so just I will be having one discussion. So here you can see that one point has been marked as yield point. So how do you know this one is the yield point? So here you can see that I will be getting the values also. So just you can see that it was I think 2.9 and then it went on to like 3.1. So just 1 degree increase in torque that resulted in a huge amount of torque actually. 1 degree theta that resulted in huge amount of torque actually. Okay? So here you can see that it was initially in 1800, 1900 and then suddenly it went to 4000, 4005 or 5000. So a huge amount of torque has to be applied actually. Okay? So this is not the torque. So huge amount of torque is actually getting required. So from this point we can say that the specimen has moved to the yield point region. Clear? So this is it. So you can just so here you can see which I was telling was there were 2.9. Suddenly the twist was very high, 4.1. Okay, suddenly the twist has become very high and then these are very unrealistic values, 90, 180, very ye chole jache. So from there you can plot that. So whenever that strain actually, the strain thing that actually, so you can directly understand it, better understand it from the stress strain diagram. So once the strain curve actually that without increasing too much of stress, once the strain becomes very high actually, you can say that the material has twisted, has moved to the plastic zone. So you plot all those things. So all these readings have to be plotted corresponding to this. So the stress and strains have to be plotted and then they have to be plotted in a graph and from there we have to compare the values so in order to get the value of the shear modulus. So this is regarding the experiment. So just you can have a look at the experiment at your home actually. So what I will be doing is, so I want to have a short amount of discussion regarding this one itself. So just since this year actually we are last year actually, or rather the last semester we don't have the videography of the things. But in this semester, from this semester onwards, we are having the videography of the things. But since we are not able to do the experiments physically, so what I have thought is I have talked to the like lab and all, so we can get the data that is in the that has been plotted in the data sheets actually. So what I am trying to do is I am trying to get the data sheets actually. So once I get the data sheets, I will be circulating it to the CR, and what you do is I will be sending you the blank blank uh, blank lab manuals. So you take printout of the lab manuals and then you plot the data on them, and then you can do the calculations by yourself. So I'll be so just today and tomorrow, just the next class, we will be completing the most of the experiments. So 6 experiments on the next class we are completing. So after that you will be having so after that there is nothing actually. So what you can do is I will be sending you 6 lab manual copies. So one lab manual copy that is totally blank actually. So you take printout of all the blank lab manual copies, and then whatever the data has been collected during doing this lab this videography practice actually. So I will be taking the data from there actually. So I will be supplying the data to you. So you fill up the lab manuals with those data, and then you have to do the calculations from your end. And that lab manual also you have to submit. So last year, actually, the evaluation was totally based on a totally based on a lab test actually. So I took a test of say some like 50 marks, 70 marks or 100 marks. So nothing related to lab manual was there. But since from this semester we are able to show you the videography of the things, or rather the set of data are actually available to us, or actually you can understand how the set of data are being gathered during the experiment. So I will be sharing you the data that we got during the experiment. So whatever is the data sheet that we have, so you copy the data in the blank manuals, and then you do the calculations from your end, and I will be helping you with that. Whatever is the calculation, or wherever you are facing any difficulty, I will be helping you with the calculation. So just you have to complete all the calculations, like 6 lab manuals you have to complete, and those 6 lab manuals you have to submit to me. So there will be certain marks on that. Say 25 marks will be on lab manuals, or 30 marks will be on lab manuals, and the rest part that I can take it as a lab viva or a lab exams, something like that. But at least this year, I want to take some amount of I want to devote some amount of marks to like filling up of the lab manuals and doing some of the calculation based on the lab manuals. So so if you find any difficulty in doing the calculations, I will be helping you with that. I can understand that you can have some difficulty since you are not able to physically do the experiment, but at least within the videography you are able to see the experiment, and the data is available to you, and the calculations are very simple actually. Just in case if you understand the topics and you understand the basics of the things, actually you can do the calculations by yourselves. So I will be sending you the 6 lab manuals, lab manuals by today itself. And regarding the field in lab manuals, I have talked to the laboratory. Maybe next week, by next week, I think it will be ready, and I can send you across to them the CR or complete the or populate the lab manuals, and you have to do the calculations in the lab manual, and then you have to submit the lab manuals also. Is it clear? Hello? So এটাই হলো আজকের experiment. Today up to this, nothing much to be told. So this is experiment number 5. So আমাদের already 5টা experiment we have completed. Next day we have like compound pendulumটা আমরা complete করে নেব next day. And I think আর বোধহয় কিছু experiment নেই. Just let me check whether 6 or 7 experiments are there. So maybe next day or next to next month, next to next week, actually, we will be completing the list of experiments. And then after that, you have to complete the lab manuals. Okay? And after that, maybe we can fix a date where I will be taking the exam. তোমরা কি exam দিতে চাও না ভাইবা দিতে চাও? So I think you can give an exam. So exam marks and আমরা decide করব later on যে কি করা যায়. So a portion of the marks will be on lab manuals, and a portion of the marks will be on exam. ঠিক আছে, lab exam or lab assessment type of exam. So that is it. কোনো question থাকলে হ্যাঁ. So if you have any questions, you can ask. So videography you see at your home. ঠিক আছে, I don't have a PPT for this one, so nothing about PPT or nothing more to be told from my end. So just মানে তোমরা একটু you go by the videography. You go to this videography. It's a nice one. A nice experiment, nicely explained. So just at your home, you go through the total videography, and if you find any difficulty at any point, we can discuss it later in the next. So any doubts? Hello. Hello.
ইউনিভার্সাল টেস্টিং মেশিন দিয়ে কি কি করা যায়, মানে যে স্ট্রেস স্ট্রেনটা অ্যানালিসিস করা যায়?
হ্যাঁ হ্যাঁ।
ইউনিভার্সাল টেস্টিং মেশিন দিয়ে
Hello.
কি করা যায়, মানে স্ট্রেস?
হ্যাঁ, ইউনিভার্সাল টেস্টিং মেশিনে you can do tensile testing, হ্যাঁ tensile testing, compressive testing করা যায়, bending test করা যায়, 3 point bending, 4 point bending, মানে ইউনিভার্সাল মানে এখানে অনেক কিছু ইউজিং অ্যাটাচমেন্টস অলসো মেনি সর্ট অফ এক্সপেরিমেন্টস ক্যান বি ডান। আর মোস্টলি যেটা করা হয় সেটা হচ্ছে টেনসাইল টেস্টিং অফ মাইল্ড স্টিল। আচ্ছা, কম্প্রেসিভ টেস্টিং আবার মাইল্ড স্টিলের হবে। ইউ ডোন্ট ডু এ কম্প্রেসিভ টেস্টিং অন মাইল্ড স্টিল। কম্প্রেসিভ লোড কে বিয়ার করে, যেরকম ব্রিক, লাইক অল দ্য সিভিল ইঞ্জিনিয়ারিং মেটেরিয়ালস লাইক ব্রিক, সিমেন্ট, all those things actually. So that those sort of things that are supposed to carry compressive test, so on them we do compressive test. So compressive test of cast iron or compressive test of like stone, brick and all those things. So compressive test you can do on the UTM machine, and then bending test. So bending test also you can do on the UTM machine. So just below the UTM machine you can see that there is a bench actually on which we can do a 3-point bending actually. So you have studied bending, so we can put one specimen on 2 supports, roller supports, and then at the middle we have a we have a thing for applying the load actually. So we can do a bending test on the UTM machine. So these are the 3 main experiments that can be done on the UTM machine. Apart from that, many other experiments can be done on the UTM machine by using various attachments. So that way it is called a universal testing machine. Many experiments. So it is universal in nature. Many experiments can be done on it using different sort of attachments. So mostly হচ্ছে tensile test of mild steel বা ductile material, compressive test of brittle material, number 3 হচ্ছে bending test of mild steel or ductile material. So এই তিনটে হচ্ছে mainly the functions by applicability of UTM machine, universal testing machine. And it is a very accurate machine. The main thing is UTM is a very accurate machine, and it's a destructive testing machine actually, so it measures everything very accurately. Anything else? আমি তো destructive non destructive test একটু বলেছি বোধহয়, তাই না? So এই যে torsion testing করলাম, what is it? It is destructive or non destructive?
ডিস্ট্রাক্টেড স্যার।
So it's a destructive test. So destructive test means the specimen actually gets destroyed once you complete the experiment. So
I think all the
you cannot
experiments we have done are destructive.
all the experiments, but hardness maybe for some components hardness may not be a totally destructive test. So say a lathe body at one point I measure the hardness, that doesn't destroy the sample actually, but still it's destructive. It's actually causing an impression on the specimen actually. And if you want a non-destructive test totally, you can have ultrasonic testing, like if there are inner defects in the material, like holes or porosity in the material, there are like ultrasonic machines, UV machines, and many sort of like machines that do some that are like non-destructive testing. Non-destructive testing is not in our syllabus, but you can study about what is non-destructive testing, like X-ray testing and all those things. Using all those things, you can like measure. You can you are able to determine the holes or any surface defects in the material. So they are non-destructive thing, and whatever we are doing in this lab, everything is destructive. Like tensile test is destructive, torsion test destructive. All those are destructive testing. আর কিছু? হ্যালো, ঠিক আছে, আর কিছু জিজ্ঞেস করা আছে? এনিথিং এলস ইউ ওয়ান্ট টু আস্ক? ওকে, সো আজকে ডিসকানেক্ট করছি। হ্যালো, ওকে, তাহলে আজকে ডিসকানেক্ট করছি। লুক এট দ্য ভিডিওগ্রাফি, যদি কোনো কোয়েশ্চেন থাকে উই ক্যান ডিসকাস ইট ইন দ্য নেক্সট ক্লাস। আর আমি ল্যাব ম্যানুয়ালটা শেয়ার করে দেবো, ঠিক আছে? উইথ দ্য সিআর আই উইল শেয়ারিং দ্য field in lab manual. So just field in lab manual, you can copy it in the lab manuals, and then you have to do the calculations by yourself. So unless you do the calculations, you will not be getting too much idea about the things. That is why I want you to copy the data and then do some calculations so that you can understand at least some of the, a bit of the things actually. ঠিক আছে, আমি ডিসকানেক্ট করছি। ওকে, ওকে।
ওকে স্যার।